Well, when we look at all the different methods, quote unquote, on how to take derivatives, you can always just flat out take a derivative. But sometimes when unique things come up, then we have the quotient rule, we've got the product rule, and here's the next one. It's called the chain rule. Let me show you guys something real quick before we get into this. Is that, whenever we do our, like, let's say our last lesson, we looked at the derivatives of the trigonometric functions. Let's say I have y equals cosine x, and I want you to take the derivative, okay? Well, we know the derivative of cosine x is negative sine x, and technically what we should have been doing every single time is then going to the variable and taking the derivative of that, which is 1. But since we're just multiplying by 1, you really just get a negative sine x, so nothing's changed. But this is a concept of what we're doing here in the chain rule. It's taking, instead of, if we look at look at this function right here, f of x is equal to cosine of 3x plus 2. Well, instead of having just an x in there, what we've got to do now is to go ahead and take the derivative of the cosine, but now we've got to focus on multiplying it times the derivative of what your angle was. Okay, so it's kind of like I did up here, where I just took the derivative of x, which was 1, but that's what we're doing here, as in general, with the chain rule. Okay, so let's go to the main definition of it. And, oh, by the way, the whole part of it being like a composite is because you can see this function f of x is almost made into two parts. You got one part being cosine x, and you've got another part being almost the angle itself. And that's what we're saying right here. You've got one function just being cosine. You've got a whole other function being your angle itself. And so when we take the composite of the two blended together, that's when we get this nice big function. Okay, so the whole key with doing the chain rule is being able to take your problem right here and break it down to those two separate functions, so that if you did take the composite, it would come back together. And that is the big key, is being able to see that and recognize that. Okay, so here's just some formal stuff that, going to the technical definition of everything. But let's go to my words more than anything. So the derivative of the composite is the derivative of each piece of the composite multiplied together, and both of these are going to be in terms of x. Okay, so it's like when I had that just above, if I had y equals cosine of 3 plus 2x, the two parts are cosine x is one part, and then 3 plus 2x is the other. So if I want to take the derivative, well, the derivative of cosine is a negative sine of 3 plus 2x, and then times the derivative of this, which is just 2. So that's kind of like what you're doing there, okay? So let's get started on some problems and we can practice with this. Okay, so with here in example 1, basically what it started you out with is the two parts. You have one part being y equals cosine u, and the other part being u equals negative x over 3. So if we kind of blended them together, or took the composite of it, it's telling you that u equals this. So y, instead of being cosine u, it's going to be cosine of negative x over 3. Okay, so now it really is a function. Y is being a function of x, which specifically they want you to find dy dx. Okay, so together, then dy dx, or y prime, is going to be mainly the derivative of the outside function. So the derivative of cosine is negative sine of our angle now, which is just x over 3, and then we're going to multiply it by just the sine of our angle. Well, just the derivative of our angle, and the derivative of our angle is the negative 1/3. Okay, so you take the derivative of the main function itself, so the derivative of cosine, which is negative sine, and don't change the angle at all, and then we multiply by just the derivative of your angle. Okay. And cleaning this up then, y prime, so you've got a negative sine times a negative 1/3, so positive 1/3 sine of negative x over 3. And there's our answer for that one. Okay, so let's go on to the next one. If sine of u is going to be our main function, y, and u equals all of this, we're going to find the derivative. Okay, so let's plug what u is back into your function. So instead of just sine of u, it's going to be sine of x minus cosine x. And then when we go to take the derivative, first of all, the derivative is just the derivative of sine. Sorry, I was going to write sine again, but the derivative of sine, which is y prime, is going to be cosine of our angle as is. And then now what we have to do is multiply by the derivative of our angle. So the derivative of x is 1, minus, and the derivative of cosine is negative sine x. Okay, so a little more clean up here this time, but it's going to be the cosine of x minus cosine x times 1 plus sine x. And if we want to leave it like that, we can, or if you want to put the 1 plus sine x in the front, but there's really nothing else we can do as far as cleaning up right this second. Okay, but if we look a little more closely, one thought that just popped in my head that we could maybe do, let's see if this gets us anywhere. If not, I'll just come back here, box this one up, and we'll call it done. But we have the cosine of our angle. It has more than one part. I'm thinking that just because that this example is really focusing on just doing the chain rule, we don't have to go this far, but it wouldn't hurt to get back and get into our trig just a little bit more. If we have, let's come over here to the side. So here's some side work. The cosine of x minus cosine x. So we are taking the cosine of an angle that has more than one part to it. And the formula for that is always the cosine of the first times the cosine of the second plus sine of the first and sine of the second. And, I was just kind of curious to see if that was going to get us anywhere. It didn't, but you can kind of see it's not really cleaning up very much, so we're probably just going to stick it right here. But, it's always good to kind of look at that again. Do y'all remember that formula? Cosine of alpha plus beta, or alpha over, or alpha minus beta, either way. It's the cosine of the first times cosine of the second, and then we do opposite signs, so it would be a minus plus, and then sine of the first times sine of the second. Anyways, we're going to probably come back to this a little bit more later, but nothing else. It's good to talk about that for just a second. Okay,